All right, so we break ethers down into kind of two types of ethers with naming, simple ethers and more complex ethers. Simple ethers have unbranched alkanes, alkanes, or common branched substituents, common branched substituents. So what is a common branch substituent again? Well, what is this thing called? That's a tert-butyl group. What is an unbranched alkane? Anything that just has a big long chain. So this one on the left has an ethyl on one side, an ethyl on the other side. So we actually call this simple ether diethyl ether. So the di means two. Diethyl ether, two ethyls on an ether. This one has an ethyl group on this side, a propyl group on this side. What are we going to do? We're going to say both of those. What order should they go in? Alphabetical order. So this should be ethyl, propyl, ether. What about our branch substituents? Kind of the same situation. We have methyl here. We have tert-butyl over here. And remember, does the tert count in the alphabetization? No, it doesn't. The tert does not count. So this is going to be butyl comes before methyl. So it would be tert-butyl, methyl, ether. So that's how we name kind of simple alkanes. So that's tert-butyl, methyl, ether. Okay, what about the complex ethers? So complex ethers, basically they're complex if there's no way to simply say ethyl, propyl. Like we can't say in one word what that whole thing is because it's kind of complicated, right? We have a branched pentane, because there's 1, 2, 3, 4, 5, and there's no, it has two stereocenters, like there's no way to easily name that. So when we do that, we have a complex ether. The ether is actually named kind of like a halide is, where it's named as a substituent. So as a substituent. And the prefix of the substituent describes the length, the alkyl length. So this ether has 2 carbons on it, on that side. So this is like the complicated side. So we would call this the prefix of the prefix. So essentially the prefix for that substituent is going to be blank oxy. So, and it ends in oxy. All right, I understand that I'm being a little bit confusing here, but I think it's going to be very simple once I say what this is called. This is called an ethoxy. So this right here is an ethoxy substituent. So the eth refers to the 2 carbons. Remember, ethane is a 2-carbon long alkane. So eth is the 2 carbons. Oxy means that it is an ether. So if we number this, again, since this is named as a substituent, it doesn't take priority like an alcohol does. So that reverts back to the standard IUPAC rules where we want the lowest possible numbers for the first substituent. In that case, the ether is the first substituent. So that's why we would number right to left. So we have 2-ethoxy, 3-bromo, pentane. So that's how we would name that one. Again, you guys are really good at RS, hopefully. These are both S's. So this would be 2S, 3S, 2-ethoxy, 3-bromo, pentane. So that's what the name of this one would be. All right, on to epoxides. All right, so there are simple epoxides just like there are simple ethers. Again, it says the same thing at the top. Simple epoxides have unbranched alkanes, or common branch substituents. And simple epoxides are numbered from the oxygen around the ring, and they're called oxiranes. So let's name these three just to kind of explain how these simple epoxides are named. So they're numbered from the oxygen around the ring, 1, 2, 3, so 3-member ring. This has a methyl in the 2 position, a methyl in the 3 position. So this would be 2,3 dimethyl oxirane. Is that enough? Of course not. There's some stereochemistry that we have to deal with. So are we going to figure out R and S for those and name it based on that? No, we're not, because this is an achiral molecule. It has this plane of symmetry. So if we named it RS or SR, we could essentially flip it over and it's the opposite. So this one, both of them are still wedges, so that does differentiate them from this one over here. This is cis 2,3 dimethyl oxirane. So how does that differ from this one? This one we could do two things. We could either name it as R and S. We could solve what those were and name it that way, or we can just call it not that one. So this is trans 2,3 dimethyl oxirane. So that would be probably the best way. I mean, you could do R and S for this one because it's technically chiral, but usually we don't do that with simple epoxide, so we'll kind of skip past that. Name this one on your own, and then restart the video. Okay, you did it. You're so good at this. So again, yeah, we'd number on the ring. This one's got 2 methyl groups on that position, so it'd be 2, 2 dimethyl oxirane, because both of those carbons are on the same spot. Remember, we need that dimethyl as well. So that's simple epoxides, and more soon. All right, epoxides are a type of ether, so it kind of follows the same rule systems pretty much. Complex epoxides, just like complex ethers, are named as a substituent. So they are not given any priority or precedent like alcohols are. They are named as a substituent. And the substituent is numbered at both positions, and it's called epoxy. So how are we going to number this one? 1, 2, 3, 4, 5, 6, 7, 8 makes it 1, 2, 3. 1, 2, 3 would be 3-methyl. But if we go from right to left, we have lower overall numbers, and also E comes before M for the substituent alphabetization. So anyway, so we're going to number right to left. And we have 8 carbons long, so our parent is going to be... So go ahead and try and name this one, and then come back. So you've paused it, you're doing that, you did a great job. Now we're back, so this one is going to be octane, and the substituents are a 3, 4 epoxy, 6 methyl octane. Again, this complex ether has a lot of stereochemistry, 3 different stereocenters here, here, and here. So all of those need to be labeled as S or R. This one is S, this one is R, and this one is R. So that would be 3S, 4R, 6R. So that would be the most ideal name for this complex epoxide. All right, see you later.